Hi, everyone. Welcome to the special edition of Meta AI Infra at Scale. I'm lucky enough to be joined by this amazing panel. My name's Irina Kofman. I'm the head of XAI, where I'm responsible for our cross-company AI efforts, working on the research to production pipeline and accelerating our AI into product. Most recently, I also took on the role as the head of product for our newly formed generative AI team. Today, I'm going to dive into some of our AI infrastructure projects with this great group of people. And I'll kick it off with some intros. Rachel first.
Great. Thanks, Irina. Hi, I'm Rachel Peterson, and I lead the data center strategy team, which looks at our data center capacity needs of today, but also ensures that we're prepared for the future. Since 2010, Meta has been designing, building, and operating its own data centers. And we've always done this with a mindset of innovation, efficiency, and reliability. And over at least the last 18 or so months, our data center organization has been really centrally focused on AI and the future of AI and preparing us for this. And so while our current data center designs have been supporting all of our AI workloads, we're really looking towards the future. And our teams have been really focused on designing and deploying a next generation data center, which is not only able to support our current needs around AI and our current products and services, but also for our needs of the future.
I'm going to pass it off to Alexis next.
My name's Alexis Björlin, and I support our AI systems and accelerated platforms teams here at Meta. Our teams are responsible for designing, delivering, and supporting our compute and storage platforms at scale. In addition to building and delivering our compute, storage, and networking hardware, all the way down to the silicon itself. One of the biggest missions and visions of our team is ultimately to deliver software-defined hardware. That is really taking into account the needs of our evolving workloads, developer efficiency, our entire software stack, so that we can deliver hardware that is optimized for the needs of our users. We're in a unique position here at Meta to do that because we've got the end-to-end ecosystem in-house.
And Kim, I know we've worked together a bunch. So.
Absolutely, yeah. Thanks so much, Irina. Hi, everybody. My name's Kim Hazelwood. Broadly, I lead the organization that provides our AI research infrastructure solutions for our cutting-edge AI research that's happening within the research organizations. So we develop things like the AI research supercluster, as well as the entire software stack that is used by the researchers in our organization. We're also doing some cutting-edge systems research as well, right at that intersection between systems and machine learning. And all of this is being used to unlock some of the latest breakthroughs in AI.
And next, Aparna, my partner in crime on the XAI team.
Well, hi, my name is Aparna Ramani, and I'm responsible for data, AI, and developer infrastructure. And so collectively, my team's responsible for all the components across the data and software lifecycle. So we start with the teams that build the systems for prepping data and having it be ready for training. We have teams that build the systems for training and inference stacks. And we also have a team of specialists that are just incredible engineers working on all of the developer experiences. So everything from enabling both machine learning engineers as well as software engineers that build applications that serve the 3 billion users that we have. It's an exciting time to be in AI, both for us at Meta, because we have this incredible, ambitious roadmap ahead of us for AI, but also just looking at the transformative power of AI across our lives on a daily basis. So yeah, it's a great time to be here.
So many of you mentioned this transformation, the impact AI has had. With the evolution of AI, how has it impacted Meta's infrastructure that you've seen today? Also, as the company evolves, we're more and more reliant from family of apps to the metaverse to our devices that we produce. How are you able to adjust your infra strategy as you do that? Rachel, do you want to kick us off on that?
Our current generation of data center designs is world-class energy and power use efficiency. And it's actually really supported us through multiple generations of server, storage, and network. And it's really able to serve our current AI workloads really well. But as we look towards the future, it's all been about planning for the future of AI hardware and systems, and how can we have the most performant systems in our fleet. And to do this, we've really had to redesign and rethink our data centers. And this is to support the future all the way from, how do we look at the building design to power and cooling, and how does network fit into the data center? So for example, as we look towards the future, we see a future in which the AI chips are expected to consume more than 5x the power of our typical CPU servers. And this has really caused us to rethink the cooling of the data center and really provide liquid cooling to the chips in order to provide this level of power. And so for that, we had to, of course, redesign the system. But I'm really excited about what the future holds in our new data center designs as we look forward.
Yeah, and as we do these things, we're always looking forward and adjusting. So right back to that question of how do we adjust for the change before the change happens? And Alexis, I know you've done a bunch of that with your team that you lead.
Yeah, absolutely. And just building off of everything that Rachel just shared, I think it should be very clear that we're designing end-to-end systems that really start from the physical side, from the data center, all the way through the network that connects our global fleet, all the way into the data center to our AI training clusters and our distributed inference serving platforms. Meta has a tremendous amount of experience in delivering distributed compute at scale, and some of the pivots that we had to take when we started building out our AI infrastructure a number of years ago was really shifting some of the thinking to deliver more highly integrated, tightly coupled systems to train our workloads and then to do the inference serving. So not only do we design end-to-end for our AI platforms in the physical side, but also all the way up our software stack, working with AI infra, working with next generation research workloads, working with our product group teams to make sure that we're achieving that software-defined hardware systems, that our fleet can handle more heterogeneity, that we're able to build the flexibility and capabilities that will service our future workloads that we don't even envision today.
Yeah, and you mentioned networking, hardware, software, and Aparna, we talk a lot about these shifts and being able to be nimble, but and plan at the same time. So how do you manage that? You're able to plan ahead, but still adjust as the market changes.
Yeah, one of the things I want to say is we've invested in AI for years as Meta, right? If you really think about it, Newsfeed was launched in 2005. And Newsfeed is really, a ranking algorithm. And then as relevance improved, like Newsfeed evolved, that's all powered by AI. We've invested in helping our users stay safe with spam detection and with removing hate speech, for example. All of that is powered by AI. And then we have, I think, one of the world's best ads platforms, and all of that is powered by AI, right? So this is really an evolution for us in infra from a very long time ago. And what's shifting now, I think, is the pace of innovation is really rapidly increasing, right? Model architectures are changing, model sizes are changing. We're seeing really complex models that are evolving, data volumes are growing. And so, thinking about the software evolution that we've had, we've done a few different things. Organizationally, we've now consolidated all of our software into the AI infra organization. So we're really well positioned to handle all of these new changes and shifts. We've created whole new software stacks, PyTorch, the leading framework of choice for all machine learning development. It was built by Meta and obviously open sourced, and now is part of our foundation. We've invested in entire new training stacks. And we've invested in inference, which is sort of like our ability to serve these models at scale.
And Kim, I know your next gen was mentioned by Alexis, and you're always looking forward for many, many years ahead of some of us. How do you manage that from a research and foundational perspective?
Yeah, in addition to all of the amazing product use cases that we just heard about, we're also evolving our infrastructure to deal with the research use case. And what's great about this is that it gives us this sort of preview of what's potentially to come. And we can kind of evolve both the hardware infrastructure, the compute, the networking, the storage, in anticipation of sort of what's coming. As we've evolved from recommender systems into more recently generative AI, then we were able to anticipate, okay, what does this mean from an infrastructure perspective? How are the demands different? What bottlenecks might we run into? And sort of how can we evolve our designs? And not just at the hardware level, at the software level as well, because we also get a preview of like the usability pain points that people will have. And so, Aparna had mentioned PyTorch. So PyTorch originated out of the research organization generally just to solve a problem. Like the problem was, I want to be able to focus on the model itself. I don't want to have to worry about the infrastructure. So let me just quickly build some infrastructure that lets me focus on what I want to be focusing on. So basically, how do I hide the complexity and not have to spend too much time and energy to be able to get what I need?
Absolutely. And you all mentioned AI transformations. More recently, Gen AI, I think nothing has captured the hearts and minds of people as much as Gen AI and been a transformation. As we think about generative AI, and you mentioned the research side, we couldn't have done the product use cases without considering that research end. How is infrastructure impacted when we make this massive change to generative AI? Alexis, do you want to talk a little bit about generative AI and how it's impacted your team?
Absolutely. The first thing that I could say is scale, pure scale. We've been delivering, we're on our third purpose-built AI system with our internal hardware designs today. And as we look to the future, it's the generative AI workloads and needs require the models are much more complex. They require much larger scales of GPUs. As an example, whereas traditional AI workloads may be run on tens or hundreds of GPUs at a time, the generative AI workloads are being run on thousands, if not more. So the actual requirements have changed as well. Our recommender models were traditionally memory or network bound. Generative AI is incredibly compute intensive, so the compute density needs to increase. So what does this mean for us when we build? We're building much larger clusters. We need to be able to shard our workloads across many different GPUs. We're thinking about how do we optimize these. The power consumption is also rising. So we've done a lot of work in advance, forward-looking, to figure out how do we cool these systems. But how do we cool them, continually into the future? These are also incredibly capital-intensive systems. So when we think about that, that's one of the main reasons we have the opportunity to innovate end-to-end, and that's one of the reasons we kicked off many years ago our internal custom silicon development, so that we could optimize our specific clusters, our specific infrastructure to meet the efficiency and both the performance, power, and capital efficiency required for the evolution of AI workloads.
And Aparna, we've been talking a long time about the product experiences, way before I think actually generative AI picked up. So how do you manage planning across all these products? Because it's not one size fits all.
Yeah, generative AI has been an interesting evolution. And I know Alexis talked a bunch about sort of the systems impact and the data center impact. I'll maybe mention a couple of areas on the software side. First, for training, these jobs run for weeks and months, not hours, right? And so fundamentally, the way that we think about checkpointing, the way that we think about scheduling, fault tolerance, being able to find capacity that's contiguous, all of this, I think, are new challenges that surface because of the nature of Gen AI. Fortunately, in Infra, we have just an incredible core Infra team that's been working on large-scale problems for so long. So we're able to sort of pull from that expertise to be able to just build on that, to be able to support these really large jobs. And it's a totally different ballgame running this in production versus, smaller versions of this in research. And to do it predictably, I think, is really hard. The other thing I'll say is on the inference side, we're finding that Gen AI requests land up being about 1,000 times more expensive than ranking a recommendation request, and just the nature of the models themselves. And so there's just an incredible opportunity. We have, I think, one of the best teams in the industry working on all of the performance optimizations here, everything from new runtimes, changing the languages of our runtimes to be more performant. We're working very closely with Alexis' team and your team, Irina, on co-designing these models so that we can build more performance into these models themselves. And we're working on really innovative, creative ways of serving these generative AI models with different tiers for different context windows and things like that. So just very exciting all around.
One of our differentiators is our open science philosophy. So when you think about open source, and a lot of that comes from your team, how do you think about it?
Yeah, I'm really proud of the work that we're doing with open source. I mean, the research teams have open source Llama, our generative AI models, and not just the models, but also the weights. And that's just unprecedented in the industry. And I think people are finding that really valuable in the community. We've open sourced PyTorch, which is the leading machine learning framework for all model development. And recently, we also handed over PyTorch to a PyTorch Foundation under the Linux Foundation to enable an ecosystem. And I think it's really important, right? As research continues to evolve at this crazy pace, you want to be able to have all of the investments be applicable to many people in the community so we can further AI research together. PyTorch 2.0 recently released with just doubling the performance. If you caught Punk's talk earlier today, she talked about Torch Dynamo and Torch Inductor as part of the PyTorch 2.0 release. Really exciting technology. So I think overall at Meta, we're committed to open source. We're committed to enabling research across the communities, and I feel really proud about it.
Yeah, and I know, Kim, your team was very good at predicting the creativity, generative AI trend coming out with some of the launches. What are other areas of AI that you see coming in the future?
Yeah, I mean, for sure, the big boom in generative AI has been amazing for the AI research community. It has opened a lot of doors, but it's also exposed a lot of investments that we need to be making as we look forward. First of all, the models themselves are really only as good as the data that is used to train them, and therefore we're going to need fundamental investments in data infrastructure, and understanding how much data we need and pruning that data. And so that's a real key investment that we need to make and we should make. Second of all, as we look at generative AI today, there's a lot of singular modality efforts. So basically, we have large language models. But going forward, we're really going to need to know how to understand different modalities besides language, and then also multiple modalities at once. So images with text, speech with video. So that's going to be an investment that we also need to make. And when we look at generative AI from a use case perspective, it's rare that it's sort of a one-shot deal. Usually there's some iterative process to generating and regenerating, prompting and tuning. And so that's going to open up the doors for a lot of tools that we're going to need to build to be able to facilitate that process. And then finally, the sky's the limit in terms of the applications that we're going to have and that we're going to see coming out of generative AI. So I'm really excited to see what happens there.
So with AI, it's really easy to create silos, right? Whether you're working on networking, development of data centers, software, how do we avoid that? Because the company is big, right? And we're doing a lot of different things. Rachel, how do you avoid that on your team?
Yeah, so I've seen quite the opposite in practical experience here. I mean, our teams have always worked closely together. But since going down this, AI in particular over the last many years here, it's really required us to work very, very tightly coupled across teams across the entire company. So anywhere from software to hardware to data center to networking, you name it. We're all moving super fast. And in order for us to really deliver a very integrated stack that is really reliable, it requires us to work very, very closely. And the success here is very, very dependent on how we can have a common vision together and how we can execute and continue to execute seamlessly across this space. So it's really been all about that. And each and every day, I'm really privileged to work alongside these industry experts as well as many others at the company, which has been great. And it's really enabled us to move very, very quickly together. So I think as we look forward, our opportunity, as our challenge as well, is to move to continue to execute in a very seamless fashion as we've been doing, but in the face of rapidly changing technology, rapidly changing use cases, both for what we're doing today and into the future.
Can I add to what Rachel said? Like,
Yeah, of course.
just this group is so amazing. I get to work with them every day. So I just wanted to say shout out to all these incredible partners that I get to work with every day. AI is one of those. It's interesting. We have to work together to make AI successful across the entire stack. But when you talked about silos, it occurred to me that it's not just about silos within the company or within infrastructure. We also really need to work hard to remove silos across the industry.
So this group is building the future. So as we wrap up this discussion, I want to hear from all of you what you envision for the next 10 years of infrastructure. Rachel?
Sure. Well, from a data center perspective, I'm confident that the data center design that we're talking about, our next generation data center, will be able to support the business for years to come. This is because we've really optimized on flexibility across power, cooling, hardware, and network, as well as fungibility to support AI, various workloads, and products and services. So I'm confident about that. But that said, this is a really rapidly evolving space. So we're going to continue to innovate on our design and really continue to think about how we can support the business as needs dictate. The other thing I want to call out as we look towards the future, of course, sustainability is really important. Climate change is really important. We're all, as an industry, working on how do we bend that curve. And so that also is a very core focus for us here at Meta and our infrastructure. And so we have our net zero target by 2030. It's something that we are focused on, is getting to net zero emissions by 2030. And that's across our entire value chain. And that impacts the way that we're looking and designing at data centers to reduce our emissions, as well as through our hardware, through our network, and so on and so forth. So that's going to be a really big focus for our infrastructure as we move forward, as well as, of course, the future of AI.
And Alexis?
Yeah, well, I certainly hope that in 10 years we'll have AI systems that will be generating and building, designing our next generation silicon and systems. But before that arrives, we're looking at, I believe the next 10 years we'll see an incredible amount of customization of application-specific and purpose-built compute platforms. We'll see tremendous evolution in the network and high-performance networks at scale. We'll have to innovate and deliver breakthroughs on every area that's a bottleneck today in order to enable the compute systems of the future.
So if that's not exciting, I'm not really sure what is. Kim?
Sure. So first of all, I'll just say that AI is definitely here to stay, right? So far we've already seen two waves of AI, right? We saw the recommender system era, and more recently we've seen generative AI. This is not going to be the last wave. I envision probably at least two more waves that we're going to see in the next 10 years. And so it's going to be really, really important that we we'll stay ahead of that, understand when the trends are shifting, and respond accordingly with our infrastructure to be able to position ourselves to take full advantage of each of the waves. So I think it's going to be a really exciting time.
And Aparna, how do you feel about these waves?
Well, I mean, I think AI, AI for infra is how I see, infra evolve over the next 10 years. We've already seen this. I mean, I don't know if you caught Michael Boland's talk today. He talked about Code Compose. We're working on AI augmented productivity within Meta, where we're actually helping engineers write code and augmenting their work and enabling them with knowledge that would otherwise be hard to find. So I expect to see AI transforming various parts of infra. And, Alexis alluded to silicon designs being generated by AI. And so I do see scheduling systems having really smart algorithms that are powered by AI. I see various parts of infra evolving with AI. It's going to be exciting.
Great. And as we wrap up, I know this is the group that keeps our services and products stable for tons of users, and also so inspired that you're building the future of what this will be, what AI will be in that infrastructure. So really honored to share this stage with all of you. And I know you'll be leading that future and building AI at not just Meta, but the industry at large. So thank you all for joining us.